Okay, so good morning. For today's class, we are going to focus on shear moment diagram. So we are going to have some practice. Prepare two questions for today. Hopefully, I can complete these two. But if not, then I will give you some hints, and you can complete afterwards. Okay. So the first question is you need to plot the diagram for the shear and moment. From this figure, okay, you have a cantilever with fixed ends on A, and they have also roller B and also point C, and the given information you are given by loads distributions, and then the distance, so all complete, but you need to find shear diagram, moment diagram. Okay, so to solve this, before we draw the diagram, we need to know the reaction force, right? The reaction in A especially, and in B, right? Because we would like to know what is happening within those beams. Okay. So why we need to know the reaction at A and B? Because we want to know how the change within the shear or moment that is affected by these two reactions. Okay. So first of all, you could draw the free body diagrams. So you could draw the free body diagrams through this figure. I think I will help you to draw the free body diagram. Okay, this is free body diagram. Okay, so let's say this is A, and then B, and then C. So we have loads on C that is equal to 2 kilonewton. We have distance between A and B, which is 4 meter, and BC is 2 meter. Okay, and the distributions for the free body diagram, we are going to simplify the loads distributions by taking the this 2 kilonewton per meter, so just multiply with the distance, which is 4. So this will be 8 kilonewton, but it will be located on the middle part here, right? The middle on 4. So this will be 8 kilonewton. Okay. So we have 2 meters from here. Okay. And then as usual, we are going to take the statics. So take the moment. First taking at B, and taking when the clockwise or probably the counterclockwise, sorry. The counterclockwise is positive. So taking at B, so we would expect to get AY. So let's describe AY. This is going through here. This is AY, and at B we have, this is BY. Okay. So let's describe. So AY multiply with 4 meter. Okay, and then negative 2 kilonewton multiply with 2 meter, and then plus 8 kilonewton, and then 2 meter again, and equal to 0. So negative 4 plus 16, 16 minus 4 is 12. So 12, so negative AY4 is equal to 12, 12 negative 12, so AY is 3 kilonewton. Okay, same way for sigma moment at A, that is equal to 0. So we are going to take 8 kilonewton and then multiply with 2 meter, and then BY plus By 4 meter, and then minus 2 kilonewton, and then 6 meter equal to 0. We're going to have 16 minus 12 is 4, so 12, so let me check, 12 and 16, so 16 minus 12 is 4, yeah, it's 1 kilonewton. So let me write here that AY is equal to 3 kilonewton and BY is equal to 1 kilonewton. Okay, I think we can move to, let me take the same picture here just to make sure that we are having the same diagram. So my suggestions is taking the diagram below the notable system. So let's say this is the, or let me write with a long line that could describe both shear diagram and the moment. Okay. Now first is we have AY, which is 3. But we do have a distribution loads that is on this system, right? So I think it's best to see these distributions. Okay, so let's say we are going to take the segments. Okay, so let me draw here. Let me move this a little bit to the left. So for the sake of our observations, let's observe the AB, okay, in between. Let's make some x, okay, let's make some x that is going to be in between 0 and 4 meter. So let's take this as x, and since we have the distribution loads and at AB for some distance x, and x is in between 0 and 4, so let's just describe this as a loads like that. But we do know the how much we have for the rate, 2 kilonewton per meter, right? So of course, if we want to make our simplification for the results for the total for x distance, this will be 2x, right? This will be 2x kilonewton per meter, okay? And this will be x over 2. This also x over 2. And then suppose that because we slice this from in between, then we could see also the internal force, which is the shear, which is V. Let's say V1. And the moment also. And for the sake of our simplification, I will not draw any normal forces here because it's not really affected by the system. So we could just focus on the shear and moment. Okay. This is important for the system and also for other type of questions. Okay. So if we would like to translate this, let me just draw this first. That is, we are going to have AY, which is 3. So let's let me use the green color. So 3 will be here. Let's say 3. Okay, 3 is there, and then what would happen? It will go down, right? It will go down. So AY is 3, and then as long as we move through the distance 4 meter, as long as we move here, we are going to see that it is having some load distribution that is having a constant rate. So remember, constant rate, and it is decreasing. So we could think that like a line equation or linear. The constant is the slope is a constant, right? So we could take this and draw probably like that. Okay, and maybe we could take the same distance here, 4 meters. But we would like to know when we take this slope down to this axis, what will be the distance, right? But I think it should be some distance, and then at B, let me write B, that point here. So let's say this is 4. Okay. So we would like to know this part here. So suppose that this is going to be x. But to find the x, I think we could just take our observation before. Okay, we already observed that we have a pieces that is between 0 and 4. Okay, and then what we can do is we can take this into our statics. Okay, for this only this observation, only for this AB. So we could take the sigma Fy, take it into 0, and we could take Ay. So this will be having an Ay here. Okay. So Ay minus 2x, right? And then minus V, okay? And then it's equal to 0. And we could determine how much we have for Ay, right? Ay is, what is Ay? 3, right? 3, so 3 kilonewton minus 2x. Okay. So to find x, what should we do? Because v is 0, right? So we could take the v, equaling it into 0, right? So we could get the x. So 3 kilonewton equal to x. So x is 3/2, okay, meter. Okay. So this 3/2 meter is the point that we are looking at here. So we could take this and write x is 1.5 or 3/2, okay? Okay, now how much this line goes down? So remember that we know that the total for the whole distribution for 4 meter is 8, right? So this is 1.5 and then 4, I think it should be a little bit to the right, but I think it's okay. So 1.5, 4. So they, after 4, the beams already feel how much stress, how much force, 8, right? So it should be, goes down 8 kilonewtons. So from this 3 goes down 8, it will be on -5, okay? It should be -5, so this will be -5. I think I will go to a little bit shifted this 1.5 just to make clear and make a good proportion. Maybe that way, okay. So this will be 1.5. So this will be 5, -5 kilonewton. So this is V, let me write here V in kilonewton, and this will be X, okay, in meter. Okay, what else do we have? We have a constant. So we just have a constant that is on the distance 2 meter. So what will happen? So we are going to have this -5, and then what will happen is, wait a minute, let me check. Is there anything wrong with my calculations? No, right? Oh, really? Should be 7. So 6, 28, right? Yeah. Okay, 7, sorry. Okay. Yeah, that's why the diagram seems weird. It's not statically equilibrium. So 7. Okay, good. So 7. So from -5 and then +7. Okay, so -5 plus 7 is 2, right? So we could take 2 and maybe we take that as our line. So that is going to be maybe, let me this erase a little bit. Maybe 2 is here, okay. So that will be 2, and then up until 6, so we have another 2 meter. So we are going to have a constant that is going to be with the -2 here, right? Which is going to be 0. So we have this area as our shear diagram. So this is to describe that this is going to be -2 kilonewton, and this part here is describing +7, right? And this part here, going down here, is describing -8 kilonewton. Okay, so that's the shear. Now actually, for the same observation for AB, so aside from the sigma of F, we could also take the sigma moment, and let's make sigma moment of the small sections AB here, and we are going to describe the moment using this M1, and then all the thing here we could make statically equilibrium. Okay. Well, let's say we name the point on the right here with a capital A, okay, just to name with some random name. Okay, so we could also take the sigma moment at those small a, and then imagine that if we spin counterclockwise as a positive, so we are going to have negative AY. Maybe I will take with a different color, negative AY with X. And then we have plus 2x, and then x over 2, right? And what else we have? I think just the moment, so plus m1. So this will be equal to 0. Okay. So m1x is equal to AY. AY is 3. So we could take 3x over there, and then minus x squared. So we get the quadratic equations. This is going to be useful. This equation will be useful for the moment that we are going to draw, because we are going to see that the moment also will get into some distance x, especially for the distribution loads. And we are going to find which distance that is going to be 0 for the moment. And then by taking the idea from calculus, as you have learned before, and especially for the maximum minimum value, how the graph will behave when you have a positive slope and negative slope, as we see here. That remember that the moment is the integral of the v, or you could say v is the derivative of n, which means that we have any graph here, the slope of this will be on v. Okay, so let's say this is the slope. Okay? We see the positive, right? This is positive slope and a negative slope. And remember, positive slope on this curve is going to be like this. Okay, and then it's going to be 0 at this point here, at the x equal 1.5, which means 1.5 becomes the horizontal tangent. Okay, the slope is 0. Okay? Remember the calculus. So let's try to at least try to take this as in a proportional way. I will use light blue colors to describe. So let's take this. So that is 1.5. So this will be probably around this. Okay. And then it will go down here. But we would like to know when this moment goes down here, what will be the distance? So we would like to know that from our equation here. Okay. So this is x when m is 0. So we could take this and equaling it to 0. Okay. And then we could pick this number and then use that in the graph. Okay. So taking that m1 is 0. So we are taking these quadratic equations and we solve the factors. So this will be x, 3 minus x equals 0. So I think it's clear that x is equal 0 and x equal 3. So this is x equal 3. So 3 probably maybe around here. So this will be 1.5 and this will be 3. It should be parabolic like that. Okay. If you want to be more proportional, you can also check the point when 1.5, what will be the maximum value for m? You can check here. I think 1.5, 4.5, so around 2 or 4.5, 2.2, 2.25, 3. So 2 point something, 2.3 maybe. Probably this is 5. Yeah, probably here. So it should be a little small, a small value there. Okay. Okay, and then the same thing we can do for if x equals 4. So we could take the system and at x equals 4, we could take that this will be -4. So we could take that into our calculations also. So we could take this and probably taking it down there, maybe around this will be -4. Okay. So this is moment. Moment is kilonewton meter. Okay. This is 2 point something, 2.3. Am I right? 2.3. So this is -4, that point. And then after that, what will happen? Look at V. V is on the positive, right? Positive axis, and then it's constant. So we are going to have a positive slope. So from that point down here, we are going to have just a normal line equation. So this is at 6 meter. It goes back way back here, right? Okay. Okay. I think if you also want to make, for example, something from here, something from these segments here, just to prove that our calculations or our graphs is correct, we could take also this one within the this subject here, and we could take, if this is x, this will be 6 minus x, and then taking all of v and all moment, let's say moment 2 for that one, and then let's say this is b and this will be the 2 kilonewton. The same way we did from this AB, we are going to see some statics also. And this is just to prove that our segment on the right for V and M is correct. So, but I don't think that will be necessarily needed if you are already understand through graphs, especially from calculus method. Okay, so I think you can just go directly like this, like I did within this scope. Right? Okay, let me just review what we did. Okay? So first, before all the calculation here, the first thing we need to do is finding the reaction force, which is AY and BY. Okay? Because AY and BY is important to be described in our picture. How much the reaction on this A, how much reaction on B. Okay, that's the first thing. So after we did statics at the first section, the second one is we could take, first is this, and maybe describing some equation from the B and from M, and then we move out through here. Or you could try from this first, and then try your roughly sketch, and then you will notice that you have some x here, and then you need to prove what is that through these calculations, and then after that we can write the numbers, and you do the same thing with M also. Okay, I think it takes too much time for just one number. I'm preparing 2 questions, especially if the loadings is not rectangle. For example, if it is a triangle, we will have more complications, because if we have the distributions is triangle, which means we could simply set as a linear equation, and then we integrate. It's supposed to have a parabolic in V, and we integrate once more, we could have maybe the cubic, right? So yeah, so in term calculus wise, that will be more works to do. Okay, so let me just give you the question here. Okay? And then perhaps if not completed, let me just give you a hint and maybe complete solutions at the next Tuesday class. Okay? And we need to discuss when we will have the finals. The finals. I think I would suggest the final will be on 6th. How about that? June 6th.
What would be the final for atomic polymer? What would be the final
Polymer.
for?
It's either you can make it early, 1 week early, and the polymer is next week, or the polymer first and then mechanics. We can do that way, but if not, then perhaps just like Monday, Tuesday. But I will discuss this again next Tuesday. Okay. For the schedule, we do still have time for discussing that. So we could make it 6 or May 30th. But if May 30th, then I think the last part of my plan, I think I will just skip that. So we will just focus on, I think, torsion, the shear moment, and the beam, the stress on beam, the flexural strength. I think it's three chapters. I think it's already a lot, then I think supposedly enough for finals. Because if the chapter is too much, also I don't think you can be focused for study, right? Okay, so let's get back to this question here. Let me just so first, this time finding the equilibrium. So find equilibrium. So let's try make the diagram, the free body diagram from statics. So let's say this is the this is 2 kilonewton per meter. Oh, 3, sorry. This is 2. Okay. So if you're given this type of questions, like you have the distribution loads, the left part is 3, the right part is 2. The way we see this load, you can think like an area, like a geometry. So you could take this as your height. This is also your height, and this is the distance. So this is the base multiplied with height. Okay. You could, if you're not remembering this type of trapezoids, then you could do, this is triangle here and a rectangle. So you have two resultants. Resultant for triangle, this is 1 kilonewton per meter. This is the distance. And then this is rectangle, 2, and then distance, 3. So you could do that way. And let's try to do that way, the simple one, make it into 2 shapes. So this will be triangle and rectangle. So this will be 1 here. And this will be 3 meter. This is also 3 meter. So let me write here, the triangle is 1 kilonewton meter multiplied by 3 and divided by 2. So this will be 1.5 kilonewton. And where does this sits? This sits on 1/3 of 3 meters, which is 1. So let's say this is 1 meter here. So this is 1 meter. And this will be this 1.5 kilonewton. Okay. And then rectangle, let me use the light blue. This is 2 by 2. 2 by 2, and 2 will multiply with 3, right? So this will be 6. And where will be the 6? 6 will be on the middle part of the rectangle, which is here. Okay? And then don't forget that we need to find AY, and then according to the picture is C, right? This reaction on C. So at the equilibrium here, as usual, we take the moment at C and at A, right? So let's say C, and take this part as a positive. Actually, it's up to you. As long as you're consistent, will be the same results. Okay. Sigma moment at C. So we have. So now we concentrate on the 1.5. 1.5. It's 5, right? Negative 5. This is kilonewton, 5 meter. And what else? It's 6. That will be what? 4.5, right? And then what else? Nothing, right? So 0. Oh, the AY, I forgot the AY. So AY plus AY multiply with 6. So equal to 0. Okay, what is it? So AY So if we try to eliminate 6, and we divide by 6, so AY will be 1.5 multiplied with 5, but divided with 6. Or let me write here. 1.5 divided by 6, it is 2.5, and multiply 5. should be 5, right? Should be 575, right? Because 1.25 plus 4.5. Okay, I think it's correct. And then one more here. So at A, this will be CY 6. And then what else? Six 1.5 and then 1.5 okay, what will be, this is equal to 0, so CY is it's 9 minus 9, 10.5, 10.5, 6, 7, 7.75, so 1.75, 75 kilonewton. And as usual, because we have distributions on AB, we can observe that AB, so observe AB in between 0, sorry, that's not equal, 0 through 3 meter. Okay. So at that point, we have, let's say, we have X as distance. This is, I would like to find out what will be the equation for V and M. So let's say this is, as usual, maybe just small a like that. And what will be this for the loads? For the loads will be, is going to be perhaps that way. We have that. So we have the total is 3. Okay, the total is 3, and let me write that this will be, we have X over 2. So we have X over 2. And we would have X over 3 around here. Okay. And then this will be having our V1. And let's say this is M1. Okay. So this will be 3. This is 3 kilonewton meter. 3 kilonewton, sorry. And then so 3, and this will be, let's say this is going to be, since we have, at the beginning, we have 1, we have 3, okay? So we could make our ratio, triangle ratio, right? So if this is 3, this is 1. So if this is X, this will be X over 3, okay? So we could take that as our ratio. So let's say this is our X over 3 from this X here. And then this will be 3 minus X over 3 for this part. And then we have, for the triangle, we could take the X over 3, multiply X over 3, which will be X squared over 9 and then divide by 2, what would be? So x squared over 6, right? X squared over 6. Oh, sorry, not 9. Sorry, not 9. X over 6. Okay, and this part here will be 3x minus x squared over 3. Okay. So basically what I did is just to take the ratio of this. So this is 3, this is 3, sorry, this is 1, and we have another one here which is x, and we have this is, let's say, y. Okay. So I would like to say that this y is equal to x over 3. Okay. And then after that, we did the sigma f and sigma moment, and we will get the equations, okay, through all through this. So we have all the forces we need. So force, it will be this yellow one, and then we have ay here. I forgot to mention the ay should be mentioned there. So this will be the ay. And calculate all these components. We get for this statics for sigma f equals 0 and sigma m equals 0. We get all the components we need, and then we can bring that equations and write down the diagram. You will notice that where you have some quadratic equations, if this is too complicated, you can just use calculator. Just find the x, the factor of x. Sometimes it's not as simple as the previous question. Sometimes maybe having decimals. Okay? So I think there will be some programs in your calculator that can solve directly how to solve the quadratic equations. If not, you can use the formula for the quadratic like this one. Okay, you can just plug in. If you have the quadratic here, I believe you will have some complex, not complex, but perhaps it has decimals. So you can try that and then use your calculators. Okay. So I think that is for today's class. I think we can just complete this on Tuesday class for this second one here, the second question. Okay. So that's all.